Hey guys, welcome to this week's Friday Focus. Today we're going to solve a stoichiometry problem, so that's part of it. And then the second half is inputting that stoichiometry problem into active. So I've noticed that some of you guys have gotten the correct answer, but putting it into the active train tracks has proven to be difficult. So the following is calculate the theoretical yield in grams of aluminum trioxide or triiodide from the complete reaction of 113 grams of iodine, according to the following balanced equation. So stoichiometry, we're going to start this problem like we've started every stoichiometry problem. We're going to write down the information that's given. So I've got my pen here. Oh. So I've got 100, gracious. 113 grams of iodine. I do my train track, and then let my units guide me. So grams of iodine on the bottom. And then my first destination here is going to be moles of iodine. With these stoichiometry problems, remember kind of our generalized path is going to be grams of A, moles of A, moles of B, grams of B. Here we're using molar mass. Here we're using molar mass. And this was the new one from this chapter. That's where we use the ratio of coefficients from the equation. Okay. So right now we're grams to moles. That's pretty easy. So in 1 mole of iodine, let me grab periodic table. So in 1 mole of iodine, we're going to take the molar mass, which is 126.904, multiply it by 2. So the molar mass is 253.8. Now, I'm going to continue the train track. So in my lecture videos, quite often I break these train tracks up, and that might be what's leading to confusion, where you're not really sure how to put it into active. So I'm going to continue this train track, and all I'm doing is letting my units guide me. So grams of iodine is canceled. So in my next track, all I've got left is the moles of iodine, so that's going to go on the bottom. And now we need to see what is my destination for this next step. And we're in moles of A. Now we want to go to moles of B. So on top is going to be another unit, moles. But now we have to decide what is it that we're trying to solve for. What is B? And in this case, it's asking us to solve for aluminum triiodide. So that's going to go up here, aluminum I3. Now that I let my units guide me, I need to know what numbers go into this step. And so here's where we have those coefficients. The number 3 is attached to iodine. So that's going to go down here with the iodine. This should have been a 2. My apologies. The number 2 should be attached to this. So we're going to put 2 up here by the aluminum. All right, so continue my train tracks here. Check out my units. So moles of iodine on top, moles of iodine on bottom, those cancel. So my last little track here is going to have moles of aluminum triiodide on the bottom. Because that's up here, it's going to go diagonal so we can get rid of it. And then our final destination on the top will be grams of that aluminum triiodide. here. And then we just use the molar mass. So in 1 mole of this, how many grams do we have? So I'm going to look up the molar mass of iodine is 126.904 times 3, because there's 3 of them. And then I'm going to add that to the molar mass of aluminum, which is 26.982. So the molar mass of this is, wow, big. 407.7. Okay. Check out my units again just to make sure everything looks good. So we got moles of aluminum triiodide, moles of aluminum triiodide. The only unit that's left is grams of this, which is good because that's what we're trying to solve for. Now, how do I calculate this? You have a choice. So you can multiply all of the numbers on the top, then divide by all the numbers on the bottom. You can bounce back and forth. So 113 divided by 253 times 2 divided by 3 times 407. So you can really solve this in any manner that you would like. But let's get to our answer here. So I'm going to take 113 divided by 253.8 equals, then I'm going to multiply that by 2, divide by 3, and then lastly multiply by 407.7, and I get my answer as 121.0. Now, the second half of this video is inputting this into active correctly. So it's great that you can get to the correct answer, but to get all the points, we need to put it into active. So I'm going to escape out of this. I'm going to keep. And I'm going to pull up the problem in active, and here it is. Okay. So now I want to put in what it is that I determined in that slideshow. So we start with the information that's given, so 113 grams of iodine. So that's the information that's given. In that first train track, we had 1 mole iodine on top. So I'm going to put 1 and then mole of iodine. And on the bottom, we had the 253.8 grams of iodine. So I'm going to grab that grams of iodine, and there's 253.8. Then I'm going to add my next train track, and I just keep copying it over. So the next one was 2 moles of aluminum triiodide. So 2 moles of aluminum triiodide, 3 moles of I2, so 3 moles of I2, and then I'm going to add that last train track, and we're going to put this one in, 407.7 grams of aluminum triiodide, so there's that one, and grams, and that was over 1 mole of that same compound. So 1, and then mole of that. Notice that it automatically helps me with my units here. So it's like, oh, hey, we eliminated these grams. Thank you. We eliminated these moles. Sweet. And then we eliminated these moles. So it tells you the only unit left is the one that we want to solve for. And then lastly, we're going to put equals and get our answer in here. So our answer was 121 grams of that aluminum triiodide. So 121, and that was grams of that. Okay. So now what I have in active matches the work that I have on my paper. So I'm going to go ahead and hit show answer, and I'm correct, and I have all the points because my train tracks are correct and my value is correct. I hope you guys found this helpful.